Dear ladies and gentlemen, my name is Boris SUČIČ and I'm coming from Jožef Stefan Institute, Ljubljana, Slovenia. In my today's presentation, I will present you Slovenian experiences in creation of curriculum for customized trainings for improving energy performance of buildings and supporting transition towards low-carbon society. The EU energy policy provides a powerful and actually obligatory context for creation of energy efficiency policy in Slovenia. Within the framework of Slovenian National Energy and Climate Plan, we have recognized that the energy efficiency is the most powerful and cost-effective way for achieving goals of sustainable development. Also, during the process of creation of Slovenian National Energy and Climate Plan, we have realized that new knowledge and skills are the necessary first step in the process of energy efficiency improvement. In this particular context, energy experts are responsible to close the gap between theory and practice and actual implementation of projects. The role of energy efficiency in Slovenian energy policy framework is clearly presented on this slide too. As you can see, our target for 2030 in the field of energy efficiency is even more ambitious than the target set at the EU level. We strongly believe that each euro which is invested in energy efficiency helps Slovenian economy to be more competitive. We also think that every megawatt hour that is saved energy helps us to be more competitive and also help us to reach the overall goal of climate neutrality by 2000. We are fully aware that energy efficiency requires systematic approach. Energy efficiency and energy auditing has a long tradition in Slovenian society. Educational program for energy managers called UREM is in place since 2008. However, our research work revealed that there is a need for tools and methods for monitoring and verification of energy saving and support for systematic reduction of energy consumption in all sectors. As an answer on all these challenges, we have recognized that there is also a need for a systematization of knowledge and preparation of integrated project that through awareness raising, education and training of key stakeholders will encourage the implementation of measures to help Slovenia to meet its greenhouse gas emission reduction targets by 2020 and 2030. The need for the systematization of knowledge guided us during the process of preparation of the project proposal. All this ended in a really unique project called the Life IP Care for Climate. Life IP Care for Climate is an 8-year-long integrated project that has been launched in 2019 and it has been coordinated by the Slovenian Ministry of Environment as part of planning. It's quite a unique project. It connects 15 partners from public, non-governmental and private sector, all coming from Slovenia. It covers different areas and activities. Raising awareness and capacity building for transition to low-carbon society is the part that I'm going to tell you more about. Sustainable mobility, sustainable construction, green public procurement, food waste, land use change and forestry are also areas and activities covered by the Life IP Care for Climate. Capacity building for the transition to a low-carbon society is a very important part of this project. During the preparation of the project proposal, we have realized that there are several barriers, but the most important one is connected with the absence of proper educational and motivational programs for the key stakeholders at the implementation level. We have identified that unfortunately more people are working on planning than actual implementation. Our initial goal was to prepare a training plan for the transition toward low-carbon society, establish national qualification platform, and execute comprehensive set of tailor-made educational activities, trainings, to meet constantly growing needs of environmental and energy experts from industry and public sector. Our initial hypothesis was that specific target group, which if properly trained, may be able to influence the climate and energy footprint of their companies, institutes, municipalities, and support implementation of complex projects. Envisioned training activities are designed in order to empower final user to successfully unlock additional resources currently available under the umbrella of complementary funds, Cohesion Fund, Slovenian Eco Fund, or Climate Protection Fund. We have realized that the main barrier is not the lack of money. The main barrier is lack of knowledge how to implement complex projects. In order to overcome these barriers, we defined 10 different training courses. GSI, Jožef Stefan Institute, is responsible for overall coordination during this action and also for the preparation of following 4 educational and training activities. training course for energy contracting, training course for energy renovation of buildings, training course for energy management in public sector, and training course for energy management in industry. Preparatory activities, which were executing during the preparation of the proposal, identified target audiences and also their needs in the context of knowledge, skill, and competencies. Activities that were executed after the project start were dealing with the data collection and the analysis of all existing training programs and similar educational activities at the Slovenian level, creation of the preliminary list of themes, also preliminary coordination with the first group of selected lecturers, creation of questionnaires for the evaluation of lectures and performance of lecturers, and at the end, all that resulted in a design and detailed specification of the curriculum for all envisioned trainings and educational activities. All that were executed in the first 18 months of the project. The final version of the curriculum is a really complex document, including detailed specification of all training activities, lectures, etc. It has 183 pages and 40 different authors actually participated during the development of this document. In the context of training modules, each module, each training course it is envisioned that the duration of each training course is 3 days. It combines 15 different lectures. Each training module is also a combination of different theoretical lectures, practical case studies, exercises. Also, written exam is envisioned. In written exam is a combination of theoretical question and numerical exercise. Training course for energy renovation of buildings. Within the curriculum, a detailed description of each lecture is given. Detailed description means description of and objectives of the lectures are clearly stated. Target groups are identified. Teaching methods, proposed literature, CV of the lecturer, and proposal of questions for the exam. Within this training course, 12 different lecturers are participating. They are practitioners coming from industry, public and private sector, dealing with energy-related issues on daily basis. Also, different methods and tools for quality assurance and control are envisioned. Participants are rating every lecture and practical exercises. Feedback information is given to the lecturers in order to motivate them to constantly improve their lectures and the performance. The following topics are covered. Overview legislative framework connected with the energy renovation of buildings, short overview with different types of energy analysis, energy auditing, monitoring and targeting, energy economics, overview of existing financial instruments supporting deep renovation of buildings, energy performance of buildings, creation of energy performance certificates, energy communities, integration of services and systems, preparation and evaluation of energy renovation projects, heating, ventilation, and air conditioning systems in energy-efficient buildings, electrical lighting in energy-efficient buildings, monitoring and targeting energy use in a complex and demanding facility. This is an example of excellent practice from Slovenian retirement homes. Many practical cases are presented. Advanced techniques for design and renovation of buildings, implementation of the most modern methodologies, detailed modeling and simulation, integration of renewable energy systems in buildings with the emphasis on using solar energy and heat pumps. Training course for energy management in public sector connects 13 different lecturers, including representatives from 3 local energy agencies. The following topics are covered. Once again, overview of the legislative framework, but this time connected with the energy management in public buildings, energy auditing, data collection and analysis, creation of energy and environmental performance indicators. This is a practical example. Key elements of energy management systems, connecting energy use with the activity at the location, implementation of the green office concept, basics of energy economics. Also, there is a special lecture related with the recommissioning approach, recommissioning and performance optimization, preparation of basic sets of measures and evaluation of their effects, based on practical implementation in Slovenian hospitals, integration of energy infrastructure and energy community planning, eco-innovation and sustainable development, advanced approaches for energy management in public sector. Also, there is a special lecture related how to maintain high motivation and ensure active participation of all team members. There are concrete examples of problem-solving method in a complex environment of public sector. Also, there are practical examples of energy management in public sector in 3 different Slovenian regions. Advanced energy services and challenges of future energy efficiency marketing are also presented, and all of that concluded in a presentation about advanced solutions and practical examples of energy management activities at the level of University of Ljubljana. Initial results and lessons learned are even better than it was expected. Curriculum has a potential to become the most important element of the future platform for informal vocational trainings in the field of energy efficiency and utilization of renewable energy sources in Slovenia. We were really positively surprised that the first set of training, even though that they were organized as online training modules due to the COVID-19, attracted more participants than it was initially expected. Unfortunately, due to the situation with the COVID-19, follow-up events were not yet organized. But until the end of the project in 2026, almost 70 follow-up events will be organized. In this context, follow-up events are quite unique concept because they are the main instrument for monitoring individual improvement and competence development of all training participants. They are combining site visit and presentation of good practices implemented projects. During the process of development of curriculum development, we have realized that there is a need for a tool which will help in optimal energy selection of optimal energy renovation scenario. Also, practical implementation experiences revealed that there is a need for such decision support tool. Due to dependence on many input and output parameters, which can be very complex, the energy efficiency projects represent a typical multi-criteria decision-making problem. There are many different methods, but there is no perfect or universal method that can be applied to all problems. The first step is always to recognize the main stakeholders involved and to define the key indicators, objectively evaluate input data and model. Also, it is important to know that during the decision process and application of any multi-criteria decision-making method, the following 6 steps must be performed: defining, structuring the problem, generating, calculating decision alternatives, formulating criteria to judge the decision alternatives, collecting the judgments on the importance or relative importance, ranking the alternatives, and performing the sensitivity analysis. In a situation when it is possible to define utility function for each criterion, multi-attribute utility theory provides complete ranking with scores. MOUT method is based on the hypothesis that decision-maker preferences can be represented by a function. Marginal utility function and weights reflect decision-making preferences, which can be obtained through an interview. Evaluation of alternatives is made in 2 stages. In the first stage, utility function transforms selected input parameters into appropriate preferences. It is also called marginal utility score. In the second stage, preferences are merged in accordance with the structure of the model and the use of aggregation function. For example, the weight sum function, additive model, which is also used in our example. Practical implementation of decision support tool was based on the evaluation of renovation options for a single-family house, which is located in the central Slovenia. Through the interview with the most important stakeholder in this context, which is the owner of the property, the following criteria were used to compare analyzed energy renovation options: achieved energy savings, investment costs, value of the property after renovation, and the complexity of the renovation project. During the decision support process, MOUT method was used to compare 5 different energy renovation scenarios on the selected family house. On this slide, you can also see the main elements of all these scenarios and the results, or actually the projections of energy savings, evaluation of complexity. Due to the interviews, investment costs were selected as the most important criterion according to the owner, with a weight factor of 0.4, followed by the value of the property after renovation 0.3, energy savings 0.2, and complexity of implementation 0.1. Based on that preference, the following results were obtained. According to the decision maker's preferences, the optimal scenario is scenario number 4, because it has the optimal combination of benefits in comparing with the costs and influence on a daily life, which is reflected through the complexity of the project. As a conclusion of my today's presentation, I would like to stress that capacity building and knowledge sharing are vitally important for the large-scale implementation of energy efficiency and utilization of renewable energy sources in buildings in Slovenia. Creation of presented curriculum required huge efforts and coordination between different stakeholders. It was a tough job, but we are really proud that 40 different experts participated in creation of our curriculum and that multidisciplinarity is in the heart of our approach. Follow-up events have a huge potential for bilateral cooperation with many countries. This can also be a starting point for future bilateral projects between Slovenia and Serbia. We know and we are sure that there are many different projects, excellent projects implemented in both countries, and those projects can be a bridge between energy experts from both countries. Our research work confirmed that there is a potential for using multi-criteria decision-making tools and methods in selecting optimal renovation strategies. Real challenge is always connected with identification of criteria and development of appropriate models that support different types of renovation strategies. That will be it from my side for today. I'm really grateful for this opportunity and thank you very much for your attention and for selecting this lecture. Thank you also for selecting this conference, and I hope that next year I will be able to be with you in Belgrade. Thank you and goodbye.